So, hi, my name is Wanjin, and today I'll talk about CircuitPython and how we taught Python programming principles to a bunch of teenagers with visualizing, with a feedback and visualization process. So a little bit of background. This is a 3-week program at FabLab Houston. We just concluded in the beginning of August, where we provided 15 high school students from the neighborhood with just a mix of maker projects and programming projects. The idea is that we want to move them from consumers of technology to being creators of technology. So this is, we apply for funding from the Python Software Foundation, and then we just put on a summer camp, basically. And today, I'll be talking about specifically the part where it has to do with Circuit Playground Express, this circuit board right here, what is physical computing, and also the CircuitPython library, and our challenges in teaching super basic principles, and how seeing that in action helps a beginner learn. Okay, cool. So let's see. So in the beginning, we went from intro to Python on a Raspberry Pi. We taught them how to actually program a Minecraft character with just a Python library. So the idea is really cute. The idea is that you can, teleport yourself by programming the XYZ position of your player, and they love that. And then we tied it into physical computing, which I'll talk about more, and actually using a circuit board that's on Arduino that you can use Python on, which I think is really cool, where they're able to make an interactive badge with, and so they also designed and 3D printed a badge cover with their name on them, or whatever character they wanted. And then we went, and after that, they learned how to log some data from the input options on the circuit board, and then they visualized it by making some pretty charts in a Google Sheets, which is pretty cool considering it's a 3-week program, and the way we strategized about this is there are different ways to learn the basic concepts, and it helps a learner when you provide the kind of different channels to all achieve the same thing, right? So sometimes at Code Park, people will ask us, oh, hey, what programming language do you teach? And I say, we teach computer science. We teach how to solve problems. And with these different platforms, it's a way to show our students that we're just solving problems using Python in different fun and interesting ways that they can relate to. OK, cool. So what is physical computing? It's really the idea that we can take the input beyond the keyboard and mouse and the output beyond the screen, right? So has anyone heard of the Raspberry Pi before? Awesome. OK, so I don't need to explain it too much. But OK, so yeah, this is a Raspberry Pi. It's a little $30 computer that's meant to teach computer science principles through fun and practical projects, right? So you can make everything from a retro arcade cabinet to a server that steals passwords. I don't know. But the idea is that we learn about, it was founded by a UK professor teaching incoming freshmen computer science. And he was like, oh, these kids don't know anything about computer science. And really, when you think about the way that computers are made, they're made to run code, right? They're made for commercial purposes. They're made to play movies. And with exposing the pins that we can connect to things like motors and lights, and using a temperature data or using a sensor data, it opens up another application that we can relate to, so that we can learn how to code Python or whatever you want to use, right? So really, on a regular computer, the way we interface with it is we type, we use a mouse click, right? And that's our input option. And our output are the responses we get from the computer, which is the screen and a printer, and sometimes, I guess, music that you can play. But with these little pins where we can give it power, there's ground, there are different signal wires, there's I2C, there's blah, 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 blah. And we're able to say, oh, hey, I want to build a really simple project where I can hook up an environment sensor in my room and I'll know who farted or something like that, which is hilarious. Yeah, or I want my plant to water itself because I have that skill. I know that I feel like the way that I learned about computer science and coding was very boring. I was like made to, has anyone done that assignment in like CS 101? You have to print like a star pattern with like for for loops within for loops. Yeah, so I was like, why? Yeah. So this is something that I care about a lot with, and that's why we kind of do this thing that we want to do, is to show kids that, hey, computer science can be fun, and in the meantime, like trick them into a profitable career, Yeah, with for your competitors. Yeah. So the first thing we did was we taught them how to connect really an LED to the Raspberry Pi, and show them, hey guys, this is physical computing. And before this, they had built like a paper circuit. So this is to show them that with code, the power of the ability to tell a computer what to do for us, we're able to program fun things. And we introduced to them the basic workflow. This is Thani on it's kind of like a really nice beginner-friendly code editor. And really, the mindset is we want to introduce them to the how to think like a programmer instead of, you memorize this and here's what happens, right? We want to teach them the problem-solving process. So we say, hey, we're going to type some Python code, and here's a library, and we're going to say that there is an LED that is attached at pin 17. We're going to run the script, and now we can type and try something in the shell. So as soon as they're able to do random things like turn on LED, but this is, or make it blink on and off, on and off, on and off. It helps us give, it helped us contextualize the problem that we're trying to solve with coding. So instead of saying, this is a while loop forever, we're able to say, hey, you made the code blink on once, can you make it blink forever? And they're like, oh, while loop, anyway. Yeah, so we did that. And here's them working on like a traffic light sequence. We also talked about prototyping and breadboarding and like how breadboard is connected. So it was really cute. They were able to sequence the traffic light where we connected a button and a red, amber, and green LED to a Raspberry Pi, and we showed them how to really program that. And I think they enjoyed it a lot too. They were like, oh, wires. I don't know. That's how I'm like. Sorry, I'm not speaking for them, but they were super into it. Okay. So finally, what does this have to do with CircuitPython? Okay, because this is a Python meetup. Just kidding. So CircuitPython is really cool. Officially, it is a Python library that allows you to use Python with microcontrollers. I think that's the official definition. But really, what happened was they just put a bunch of RAM or put a bunch of memory onto like an Arduino circuit board so people can run Python on it. Yeah, that's it. It's kind of funny, really, because has anyone worked with an Arduino before or a microcontroller? Okay, so with a little bit of background on microcontrollers, there's usually very, very little space where you can save or you can, like, number one, save your code, and number two, have access to a set of pre-made libraries, because there's literally not enough like space for that because of the way it's made. And really, what's really cool about CircuitPython is they're like, oh, we're going to solder a bunch of memory onto this Arduino so people can use it to do projects and learn around it. And so we chose this specific platform to teach our students that, oh, hey, guys, remember all the breadboarding you guys did? You need to do that. Here's a circuit board with a bunch of input and output options for you to play with. And it has, so this is called the Circuit Playground Express. It's one of the many boards that you can use CircuitPython with. And actually, if you went to PyCon 2018 earlier this year, they gave everyone a little CircuitPython board. And Adafruit, the maker of this specific board, actually did a workshop where they teach you how to use this. So it's really cool because usually Python, like you're not able to, so CircuitPython enables you to use a preset, use a bunch of functions in a library to do stuff on an Arduino, which is that is easier than the traditional Arduino development environment, which is a bunch of C code. Yeah, so it has these NeoPixels, which are really nice and bright RGB LEDs. It has a bunch of input and output options. So the code that came on here, this is, I kind of like broke this, by the way, so I apologize for the lack of like real-time demonstration. But when you turn this on, these little LED lights will be red, green, and blue. And then you have input options like this little eye. This is a light sensor. So it gives you data about, it's like a number, it's like an 8-bit number that gives you data about, that measures luminosity. And here's a temperature sensor. And here is a sound sensor. It measures the decibels. Yeah. And it has a little buzzer. It has buttons. So this is really cool because after we did the Raspberry Pi physical computing, we're able to recreate the same experience on the CircuitPython to show students that really code is just a way for us to solve problems. It doesn't really matter what platform or what IDE or software you're using, right? So they're able to say, they're able to immediately, this is the same thing as before, is pixels.fill. It turns all of the LEDs on this circuit board red. And this is RGB data. So they were able to, and this kind of feedback and visualization is really helpful for beginners to learn about basic concepts while going through going through the REPL, basically. So they were able to type this and then do something like that and then change things in the REPL, which I think is really cool because this leads to the next part where we talk about what do the numbers mean, right? And we introduce the concept of a variable container by having students write down, this is the red, blue, and green value that I want, and this makes purple, right? And then I segued into like Instagram and how everything on Instagram is basically like a math equation with filters. Yeah, it was cool. So because like my complaint about the equal sign is that in math, the way we grow up, when we solve like an equation like mx plus b, whatever, the equal sign implies that what's on the left side of the equation is the same as what's on the right side of the equation. But in programming, the equal sign is actually an assignment operator. It literally means, hey, put this stuff in the right side into the left side. So with an exercise like this, students are able to immediately say, oh, this is what a variable container is, and it's just some value. And it provides a nice context and a goal to solve towards. Yeah. And what did this do? So they did the same thing. They made a pattern, and instead of programming the sequence of traffic lights on the Raspberry Pi, we were able to show them, hey, this is what you program on this circuit board with a different library, but it's the same stuff, you know? Okay. And then, so Boolean operators, yeah, this is also a really hard concept to explain, but I forgot what my complaint about this was. But with the Circuit Playground Express, we're able to provide the same kind of context and say, hey, a Boolean operator is just saying that, is it true that this button is pressed? And when this button is pressed, do something. Is it not pressed, then don't do something, right? It's the same kind of contextual problem to give to students so they're able to take ownership of the problem and do something about it and say, oh, I can solve this. I know what this means. This isn't like some random hard stuff. Yeah. Okay. And yeah, don't get me started about So, and once again, we're able to explain contextually what the while loop is. It's just when you want something to happen forever, maybe, yeah. And let's see. And so this is a combination of a while true so it's evaluating a Boolean operator, and we taught them to replace the true with evaluating whether or not a button is pressed to start off this code. And once again, we're like, hey, can you dim what do you guys think this code does? Okay. No, yeah? Yeah, so it just dims the LEDs, right? So we're able to say, yeah, we're gonna dim the LEDs instead of make the numbers smaller. It's to give them that kind of like, this is what that represents. Yeah. Okay. And I wanted to share some resources we used, which is the trinket.io. So this is the trinket.io link, and we're able to go through the basic concepts, except for dictionaries, just by saying do this and do that on the Circuit Playground Express, whether or not it's programming a sound or reading temperature or other stuff. And yeah, and let's see. So after that, we actually taught them how to do data logging. So the idea is that you can write on a text file on the Circuit Playground Express with any kind of data that it's collecting. And then we came back and we said, oh, hey, like, try an experiment. What happens when you put it in the fridge? What happens when you shake it around? And we're able to show them how to make charts and what those charts mean, which is pretty cool. And on the last day, I showed them how to use an Arduino, again, with these like NeoPixel strips. They're much, yeah, he's ahead of his time. He's already like wearing it, which is awesome. So, so I came back and I said, okay, this is, again, the same stuff, right? Like, what do we recognize? And in the Arduino, the void setup is the same as, you know, it runs once, and then the void loop runs forever and ever and ever again. And I was able to say, hey, remember the while true loop we had in Python? This is the same thing in the Arduino, but in a different kind of programming language. So I think we were pretty successful with our program, because I literally had a meeting with our Fab Lab partner, and he shared with me an anecdote, which is really inspiring, because one of our students, Monica, she actually was able to use the correct terminology in terms of the Arduino Circuit Playground, the Circuit Playground Express story and representing colors with the NeoPixels. So because I guess she was working on a project and showing people her project, and some random, I guess, like one of the people that gave the money were like, oh, do you actually know this? Can you show me this? Like, what if I want to change the colors? And she's like, right now? Oh, okay. Like, she didn't get that he was kind of condescending, so she just, without our supervision at all, she just, you know, unplugged it, reprogrammed it, and showed it to him. And I think that's really cool, because with a lot of like teaching people to code programs, especially for kids, like, it's just like, just because you use an iPad app to make like a robot run, I don't know if you actually learn what we want you to learn, you know? So with this kind of program, I think really is where we want them to be, which is letting the code to be your paintbrush. We're using the computer as a tool, and the computer, yeah, let code be your paintbrush, computer your canvas. Because at the end of the day, we're just solving problems by understanding how adders work. Yeah. So yeah, that's it. Yeah. Okay. Any questions? How long was that? I don't know. 20 minutes. Okay. Yeah. That's it. Cool. Yeah. Yay.
If you have any questions or anything, feel free to come over to the mic. agreement. Either way.
Wow. Yes, ma'am.
Would you be moving forward to more complex computer science principles like, O notation and like hash algorithms and stuff like that?
So complex for us in Python is like tuples. I think that's something worth exploring. Yeah, I think it's hard to explain like the big O notation without a certain background in math, and I think the deal is to like trick kids into. So that is something that we recognize is sometimes when you show most basic way to like sequence a light pattern, they'll take forever, and you're like, oh, remember the for loop thing we talked about? And I think that could happen, but we're not there yet. So maybe at the next workshop and curriculum we develop, where you can help us. Yeah. Okay. Yeah. Yes.
Oh yeah. So I'm just curious, like when you really like talk to the kids, like do you teach them like how to debugging? Is the fun part?
Yeah, debugging is hard. The key with that is you have to make sure they feel like they can solve the problem themselves. So with the most obvious errors, we see right away what it is, and we'll just simply point out, oh hey, the computer is like, it only reads instructions in order and does things a certain way. Might you try this? And I think the specific editor that we used also helped. So one thing that we do while we teach is we make mistakes on purpose, just so students can see, oh hey, there's this like teacher, and they make mistakes too. So I got this, So that's how we deal with that. Yeah. Yes, sir.
So I've never heard of code park before. Could you take a second to tell us what that is? And
oh my gosh, yes, that's literally why I'm giving this talk. Thank you so much. So CodePark Houston, we're a 501c nonprofit organization where we provide high quality computer science education in a way that empowers students to underserved students in Houston. So if you want to volunteer with us or give us money on Patreon, that would be greatly appreciated. Yeah, so we have classes like, so we think that, like teaching about technology and computers, it's really important for the future and for the jobs. But I think the thing that we're most concerned with is like really letting students know that, hey, you have a choice. You can go into this if you want to. And I think arting is a great way to do it. Yeah, and that's really what we do. We do creative coding experiences. So we'll show students things with like processing or P5, where they can make little web pages and like art and stuff. And then we also do programs on the Raspberry Pi where we teach them how to like be a musical DJ. So they use like code to trigger sample beats with the same concept. Yeah. Thank you for asking that question. That is the most important question of best. Sorry, Julie.
well, if I can, so the second part of the question was, what's your connection to them? What are you?
I'm a co-founder. Yeah. Yeah. So yeah. Oh look, here's my about page. Yeah, let's look at me real quick. Yeah. Yeah. So we started just last year, and it's been really great because I think we're at an awkward position where the teacher teaching our kids aren't equipped with the technological know-how because we just didn't grow up with it, right? So how are our kids supposed to learn about computer science like that? Yeah. Yeah. Anything else? Okay, great. Then you guys have absorbed everything I said. Thank you. I'm such a great speaker. Okay, thanks.